I wonder if we could do something where we like kind of make like an adapter for the plug-in where the other one would plug into.
motherfucking Ron O'Neal or something? Talking about I better pay her here. Yo, bitch, nigga. What you gonna do?
Right. Alright, I'm a little late, but I think we can get this thing started here. Always preparing. I let the kids watch that, and I probably shouldn't have. It's just too funny, though. Okay, hopefully I can hear everything tonight. I downloaded Fusion 360 onto this computer. I gave in to temptation, and I did it. Gotta force myself to learn the new software. Though I'm slower in it, so it's what I should be using. Let's see what else we got. Stuffs. Oh. Cool. We got some parts in finally. We can take a look at doing our King of Hearts here. Oh, you know what I don't have? I don't think we're not using it for this build anyways. I got some more of those Furious FPV stacks that you were showing me. Lone Star, that real tiny stack. It is pretty nice. That would go in this guy really well, wouldn't it? Because right now we have this designed with the video transmitter off the back. But with that stack, with that Furious stack, it could all go right in the center. Anyways, what we got? So picked up some stuff. I've got this, what is it? HGLRC. And that's like that's another mini stack here, but it's a ESC and flight controller stacked up And it's
Matte Fender Nano Unify and put underneath.
got a socket. Nano Unify. Yeah. I like the feel of these boards. What is this? HGLRC. The F428. Okay, so what we got here. Man, this stuff is tiny. Oh, it passed QC, it says. I need a little bit better lighting up by my camera. What's this look like under the microscope? Too big? That fills the screen, but it's there.
Matte Fender, I have 2 of those and they're nice.
Is it?
VTXS could be a bit questionable.
The VTXs? I didn't get a VTX,
Matte Fender
right?
there.
Yeah. QC is passed. Let's see what do we have on this edge. Our S-Bus, our Spectrum, 5 volts, ground, but this has OSD built in, so that must be, there's a camera in and a camera out there. That's going to be camera in, 5 volts, and camera out, VTX, battery, USB, an actual button for booting, that's nice. Hate the jumper, jumpers are terrible. Hookup for LED. BB, what's that? Top of my head, I don't know what that is. Maybe I'm just a little behind the times here. The back, what do we got? Current sensing, RSSI. That's all for side for USB, 5 volts, another receive line. Another BB. Receive 6.
Matte Fender, I have seen some complaints on them, but I think they overrate their amps and people burn them on 5-inch.
Oh.
On 3-inch 4s it's been fine.
Well, that's
Matte
good.
Fender BB I think is buzzer.
Battery buzzer? Is that what they're calling it? Okay. It's got this nice little socket right here. A really fine pitch 8-pin. And that's what is going to allow it to attach to the 4-in-1 underneath. There's our little goofy dinosaur. Here's our 4-in-1. And ooh, look at that, a pass-through for the voltage. That's nice. That's missing on almost every 4-in-1, right? I've got the big pads on one side for the battery to come in. On the other side of the board, I have 2 small pads, or through holes rather, in order to get voltage to like secondary device, like, you know, full battery voltage up to the flight controller. That's nice. I like that. I don't see that on most of the 4-in-1s. And there's our like 8-pin setup right there in order to jump up to the flight controller. So that's cool. Take a look at the other side. Don't worry, guys. This thing passed QC as well. So, well, somebody out there knows.
Matte Fender, I put a 35V470 cap on that pad.
Oh, the cap. Yeah, that's right. It comes with a cap.
Matte Fender, or maybe it was 330, I don't remember offhand.
Yeah, this guy came with a cap. And you're right, the cap will go on there real nice. And what is it? Nope, that's not the side I want. There we go. The 35 volt. 1000 microfarad. Farad. Oh, cool. This is nice. The wires actually have some color coding on them. Because every single time that I put a capacitor on, I have to look up which leg is what. I never ever remember the polarity because I don't do it every day. That's why. When you don't do it every day, you gotta double check yourself because it's so easy to make a really dumb mistake, like put that thing on there backwards and watch this thing let the a little more than let the smoke off. It'll give you a nice little pop if you put that in back.
Matte fender, the side with the line is the ground.
Yeah. It's also the length of the legs are different as well, right? So positive is always the longer leg. But I had a oh, right here. I'm a liar. This one looks like it has the same length legs. Oh well. Anyways, what do I got? I got a little. These are the caps I use. Microscope. That's the cap that I put on most of my stuff there. But it kind of looks like these legs are the same length. Unless I clip this one. I don't know. Anywho, you got the stripe. Stripe for ground. This guy sandwiches together. That's kind of nice. And it comes with standoffs. The right height for that. It's going to be 2.5 millimeter hardware to get through those holes. This guy's a nice setup here. Back apart here. I'm going to slide that back in for a second. Take a look at some of the other stuff. I kind of like what Hobbywing does. So I am curious about these two guys here. Hobbywing's 20 amp 4-in-1. And it's just too bright up there. And they're a 4-flight controller, right? This is part of this X-Rotor Nano series. All this stuff has OSD, right? OSD, yep. You have OSD built in. Anyways, take a look at these guys and see how these are. They're certainly packaged the nicest out of all of these ones here. But that doesn't mean anything. This gives you a nice first impression. Okay, what do we got? Ooh, this guy comes with a cap, a smaller cap, and lower voltage as well. Let's see. This guy has a little 25 volt 470. It also has your like ribbon cable and some battery wires, and that was with the 4-in-1 speed controller. And pop this guy out. Okay, so this, we don't get that cool socket. This one we have to run that like ribbon cable up. But it isn't too bad. Got our 2 pads there. Let's see if I can zoom out on my microscope at all. What kind of range does this thing have? Not more. More. Oh, can't figure out which way my hand works. This way? This way? This way? This way? Up? There it is. That's really hard. Okay. So there's the 4-in-1. Still pretty zoomed in and hard to see. Anyways, top side and our bottom side. This isn't gonna work because I don't know which way my hands are supposed to go. Up. There we go. So this is the hobby wing, and it has a pretty healthy coating of like conformal coating on it, and that conformal coating is like masked away from the pads that you have to solder on. Here. Yeah. So this thing is like all lacquered up. You can see kind of how shiny it is. But they were able to see if you can catch the. There you can kind of see where they've masked around the solder pad there. The build quality just kind of doesn't look quite as nice as the HGLRC. That looks built really well. It's just a shame that their branding looks absolutely ridiculous. I was expecting it to kind of be the worst one. Let's see, flight controller. So we got Hobby Wings little flight controller here. And there's our big giant F4, our USB, our boot button. I like this boot button. It's on the edge where you can actually get to it. That's nice, because once you got that stack built, getting to those other buttons can be difficult, so an edge button is really nice. And let's work our way around. There's our header for our like ribbon cable down to the ESCs. Buzzer. Ground 5-volt LED.
Matt Fender, the other thing with HGLRC, since they're using those pins, it can get a little tall.
Yeah, let's see. The HGLRC, which I can't even say. Where's their little kit? Let me take a look at the size of those standoffs here. 5mm. So not terrible. But yeah, you can definitely get it down tighter with the other stack. Let's see. Back to the this hobby wing here. Let's see our voltages. Transmit, receive, S-bus. 3.3 volt right on the edge. I didn't notice the 3 volt on the other one. And there's no more pads on the back. I'm gonna guess. Right, my spectrum is just gonna go in. It's gonna go in one of the transmit
nice, but
receive lines.
It adds height.
That's not bad. I'm gonna pull out this HGLRC again. Take a look if there was 3.3 on there. Oh yeah, there's 3.3. Okay. And right between the S-bus and spectrum pad, there's 3.3 volt. I don't know. This board's laid out pretty nice. And I don't know. This hobby wing looks really easy to solder to as well. I think it's gonna come down to what chat wants me to install in this thing. What's this last one? SpeedX. So this isn't the flight controller. This is just a 4-in-1. I think this is relatively new. I can get it open. Okay, there we go. It's wired up with a little ribbon cable, and take a look. These are nice wires, or if they are the crap wires. Nope, silicone. So nice wires on there. See, our battery wires are kind of odd on this one. They go to the center of the board. So I'm not sure if that's a good thing or a bad thing yet, but when I saw it, I thought that was interesting. That we hit the center of the board with power, and I would imagine that allows this board to be a lot more compact than most boards, because you can have chips on all four sides of this board, right? So everything is packed in way, way tighter. I'm curious to see if this thing, if it builds easy like this, because I don't think it really is going to matter, right? The wires are already pre-soldered on there. All I have to do is cut them to length and throw an XT30 on there, and we're good there. See this side here. So there's going to be the header for the little ribbon cable there. And like I said, pretty dense board. No room for any additional pads there. I guess what it saves you is it saves you a little bit of room front to back, right? It still has the wings on the side of the board for the motors, right? So like that would be your wing, I'm gonna call it, but then it doesn't need any kind of extension along the top or the bottom edge. So I guess if that was a concern, that you kind of save some space that direction. Marty, what do you think? Which one's got better components on it out of these things? Or are you paying attention to Special Project over there? Marty, where'd you go? Bad. I don't know. What do you guys want to see? There's our frame. There's our frame. Here's our frame, and we got a whole bunch of choices for electronics. So, I don't know. One of you guys is going to win this thing. So, I'll let you guys decide what you want to throw on there. We could even throw on that Furious board too, although I don't have one at the desk. Could do the Furious with this there we go. With this Speedix. I thought it was interesting. It's rated 25 amp. And what is it? Our Hobby Wing is rated at 20. And our HGLRC is rated, I don't know, 28 amps? Ooh. I guess that goes to what Fender was saying, that people can blow this up because it probably can't do 28 amps for very long. But I like the plating on this board. You know why this board looks nice? It doesn't have any sort of conformal coating on it. That's why it looks so nice. The other ones at least have a little bit of coating on them, which, although it doesn't look as nice, probably better. Fire up SolidWorks here. And Fusion. Ooh. Free sticker. Alright. What else we got? Oh, we got these in too. So, Marty, pay attention. These are for you. I got a whole whole box of these things. So this is our power supply for our timers. For our Delta 5s. These are the adjustable power supplies that are going to go inside the timer boxes. But actually, I have to model this up and see if this thing's going to fit inside of the box. And hopefully it fits inside the box as I have drawn it. Because I've got the aluminum cut. And there's no way to add it back on, is there? Actually, we saw the other day that you can glue this aluminum together and still machine it. I don't know. Lone Star, you do stuff like that? You glue this stuff together and machine it? It looks actually like it works pretty
William Hoth Furious has current sensing. We'll need it for the 5-minute race.
Oh. That's right, the Lone Star spec. Which one else? Should we have current sensing on you? Let's see. No. I think this HGLRC one does though. Oh, it could be wrong. No, it does. So this HGL, it has current sensing as well. That would cover our 4-in-1 and our flight controller in one shot. The Furious we could pair up with either the Hobby Wing or the Speedix, the new Speedix 4-in-1. Too much stuff on my desk now. Let's see. Clean this up here. Get rid of some of this. Okay. Instruction manuals, we don't need those. Okay, that's better.
Map Fender, no it doesn't, at least mine doesn't. I think the FC supports it, but the ESC doesn't have a shunt resistor.
Ah, I see what you... Oh, yep. So that's going to come down to the 4-in-1 having it. Gotcha. Do any of these 4-in-1s have... No. Okay. So you're right. The HGL does not have current on its 4-in-1.
Smarky FPV, hell yeah.
And there's nothing on the Hobby Wing. And it doesn't look like there's anything on Speedix. No.
William Hoth, the Furious stack has a nice place for the FRSKYRX on top of the VTX.
Yeah, it is a nice stack, isn't it? I opened one up. I was bad. I opened up one of the inventory boxes to take a look at it. I put it back together though. We'll probably end up using that. Okay, so what do we have? What 4-in-1s? Do you guys know of any 4-in-1s out there that have the current sensors on them?
Smarky FPV, that's what she said.
We don't, I guess we don't absolutely need it, but it would be nice to have. Anyways, over to SolidWorks. There we go. Timer box. Oh, Smarky, I got some more stuff for you to hand out. You think you can take care of this for me? And who's going up to Canada on
Smarky
Saturday?
FPV Suite.
Smarky, you going up to Canada? I think Fender,
Matt
you're going,
Fender
right?
me.
Okay.
Smarky FPV will be on a cruise to Bermuda.
Oh, that's right. Man, you really stink at this. Every major race, as long as you're not gone for the bando, that's all that matters. Okay. Here is where we left off in the Delta 5 enclosure. I modeled up the top of the light stand while we were away, because we had put this hole in the corner, and this is why I wanted to put that hole in there, so that we could throw it on a light stand.
Smarky FPV BR.
And then this will be like a little 1/4 hole here. You can tighten up.
Smarky FPV BRB.
Well, that makes more sense. Okay, so it's getting a little bit crowded inside this box, and I still have to find room for 2 of these power supplies, right, Marty? Okay, so I don't have this, so we need to model this little part up real quick. What's this thing yelling at me for? Oh, okay. Bad mate in there. Okay, so I'm gonna throw a new part in here real quick. Chat, you decide what kind of electronics we're gonna throw inside of this thing. And I'm opening a new part. And let's get this self a little room to work here. Ooh. Oh, don't, these are slippery. Throw those. Okay. Let's draw it up real quick. Oh, Marty, the components on here are so tall. They are so tall. I'm starting to get worried. I have all that aluminum cut already. Oh. We can find a solution, right? This reminds me of back in the great old days. Marty, listen, the mechanical guys got ahead of themselves. Now it's up to you electronics guys to figure it out.
Cram nitram yet, buy the ones it's designed for.
Listen, Marty, those things were many times more expensive, so this is what we're doing. You should be used to this. Okay, I'm measuring up my board. There's my start. And let's see. Oh man. I've got 2 giant caps on either side, right? I'm just gonna mirror these. Make my life easy. And let's get a rough idea. Not super critical the layout. I just need to know like kind of the overall envelope that this thing sits inside of. I'm gonna go from the outside to the outside of my 2 circles here. That's easy to get calipers on. And I'm going to make an assumption that those are in the center. Are. Well, the bottom of the board's flush. That's nice. 12.1, I'm going to add just a little bit in there just for some safety. Okay, so those are my caps. And let's put that trim potentiometer in there. I think that's what that is, right? I've picked up a thing or two from you electronics guys. Trim pot. 8 by
Cram Nitram, you can get one off
9.5.
of GrabKid.
This exact thing?
Cram
Now you tell
Nitram,
me.
yes.
Now you tell me. Well, what's the fun in that? I'm almost done now. How detailed is that guy over on GrabCAD? We're just gonna get the major items in here. Then I'll feel comfortable about it. Six minus the width of the board. We got one more component over here. Point 2, and then minus the thickness of the board. Okay. Are those mounting holes? Right. Those aren't like for soldering, right? Oh, those are mounting holes. Okay, so I'll pick my hole feature. It's probably a metric screw clearance. It is like 3.1. Oh, yeah, that's definitely an M3 normal hole. Got one there. And we've got one in the opposite corner. So I'm just gonna kind of. No, can I mirror it over there? Can't do a mirror. I can do a circular pattern. Just 2. And let's get some measurements on this thing. These are going to be bad, these measurements. I'm going to say that's like 6.5. I definitely don't have the right tools to measure this. I'm going to say that's 2.75 direction. Okay, so why is this one still floating? Floating. Because I deleted my other thing. Okay, let me try that circular pattern one more time. Ah, how silly. I will lock that thing in place with a construction line. Because if I make the midpoint of that construction line coincident right there, it will lock it. There we go, fully defined. There's my board. These are actually too tall. Right, okay. Where is it? There it is. Uh-oh, Marty. What do you think? Is it gonna fit? It'll fit in there, right? Room right there. Maybe we can turn it on its side. Throw it up against the wall right here. That would take care of one of them. Now we just have to deal with the other one of them. Ooh, that looks like there's a spot right there. We might be in luck, and I don't have to throw out $200 worth of aluminum. That fits right there. Don't have to use the USB. Is that what those are? I think that's USB. That's USB. Yeah, okay. Oh, they're labeled right there. Yeah, so I think we can block those USB ports. This guy right here. Perfect. Plenty of room. Just going to be a little tight on that Ethernet port. Yep. Marty, we're good. Plenty of room. Alright. I'm just going to start cleaning this up. Put some mates on there. Find some sort of like 2mm spacer. And that's how we'll put that on there. We can lift this up off the bottom by a couple millimeters. 2mm off the bottom. I can go right there. Same thing for this one. Up 2mm off the wall. Like 2mm off the floor. A little uncomfortable. But I don't know. Good enough. Okay. That's not going to require too much modification. Still good with our stock size. So, I don't know, chat. Make a decision on what electronics we're putting in the King of Hearts. You guys figure that out. Let's pop. I'm going to pop over to Fusion. I don't know if we can handle everything at the same time. Let's kill that. Fusion here. And I'm gonna start laying out the CNC programming for that box. And I don't want to wait for mill time. Although I would like to get a video of it running on like the Haas. I was thinking that I would attempt to do it. I'm not going to be patient here. That I could attempt to do it on my router. Now my router is not rigid like a mill is rigid. So what I'm going to have to pay attention to is how much force is being acted on the spindle here.
William Hoth been playing with Fusion.
Okay. So there's the timer box exported from SolidWorks and brought over into Fusion. And in Fusion, I've added another feature just because I was playing around. Oh, I added some blind quarter 20 holes in a grid to the underside of our timer box, and that's to like give me more options for mounting this thing. I think that's one of the shortcomings for the immersion timer is that it doesn't give you any way to mount it. All it needs is a couple like quarter 20 holes, and it can hook up to, you know, any sort of like generic, you know, camera gear or lighting gear. So like I said, we've got this 5/8 hole bored into it for a light stand, but then I'm going to give myself these additional quarter 20 holes on here and what's kind of called like a cheese plate. Same idea as a fixture plate in a CNC, right? Just give yourself lots of options for ways to attach. So anyway, those I modeled in Fusion 360 just to kind of see how it was, and I'm not crazy about the way that Fusion did it, because Fusion gave me all these whole operations as like, I don't know, separate operations, even though I completed it, you know, with like one mouse click. I don't know, not crazy. It seems like if I go and I edit one, only one of them updates. It doesn't update the whole array. So I don't know if I'm doing something wrong, but I don't know. I wasn't crazy. I did these holes in Fusion because I was kind of under the impression. I was kind of under the impression that if Fusion saw these as quarter 20 holes, that when I go over to the cam side of Fusion, that it would recognize those as a tapped hole, and that would help drive the programming. But it does not seem to matter at all whether this is a simple hole or a feature. It doesn't seem to matter. The tapping and threading in Fusion doesn't seem to be complete yet. One of the things about this software is it is like living software. It's a work in progress. It's always being updated. So Marty, what are you saying? Am I wrong? Like, should these not be separate hole features? This was the third time I attempted making these holes, and I don't know. I don't see how I get one to update all of them. I did a sketch, and the sketch is just a bunch of points in an array, and then I attached my threaded holes to those points, and it gave me a whole bunch of these. I don't know. I like the way SolidWorks handles it, unless I'm doing something wrong. Marty, you say I'm doing something wrong? It's possible. Okay.
Nitram, you do one feature and then do a feature pattern.
One feature. Okay, I'm with you there. So you're saying I deleted all those holes. Ah, they're all gone. Okay. Nitram,
is your timeline on?
I don't know. What's a timeline? Let's see. Hole, right? And you're saying just select one instead of the whole entire. See, I did this like from sketch multiple holes. You're saying no, don't do that. Let's see. Okay, so a tapped hole and fully threaded. No. Yes, fully threaded, flat bottom. 5 millimeters deep. Oop. Where am I going wrong here? Oh, okay. quarter 20. Where are we? Quarter 20. Kind of a regular loose fit is fine. So that bottom millimeters. I got to get used to when you can and can't hit the enter button. Okay, so Marty, are you saying if I do one hole, and it looks like it's given me, so it gave me the minor diameter, and do an array of that thing? Object, that thing.
I can't see the bottom of your screen.
That's it. There's nothing cut off except for my start menu.
Do you see the little gear in the bottom right-hand corner?
No. No gear. Bottom right? No. No gear.
I think the problem is you're in direct modeling.
Direct modeling.
Fusion works like on a timeline. So
Yeah,
if you
I
do
recall
stuff,
that from, that's probably because I imported this from SolidWorks instead of starting it.
correct.
Yeah.
But you're not going to be able to grab the feature to do the pattern without having it in the timeline.
I get you. Is that why it doesn't seem to be making a rectangular pattern here? Oh, direction. Maybe that'll help. Direction 1. Oh no, that worked. Ooh, look, it says thread. It says hole here, it says thread there. But does it always list these all as like in the tree as like separate things?
Smarky_FPV hello.
Hello, Smarky.
I don't believe it does that if you're in the timeline.
Uh-oh. Marty, why do I still have these two holes? Okay. Alright, back to the way I had it. I don't know where the timeline is. Let's move on. Shall we? There we go. Multiple holes. Okay. Hole, tapped, full, flat bottom, 5mm, quarter 20s. Okay. So that's that. And now popping over to cam. Okay. So I was playing around with it so that I wasn't a complete idiot trying to do this live. And I started a couple setups. Setup 1 is this top face here. And then setup 2 is the reverse side. And then we would have a third setup, which would be this face, because we've got to clear out room for the Ethernet port on the side of it. And then technically there would be another setup for this quarter 20 hole over here for a thumb screw, but that to me looks like something we can do by hand in 2 seconds versus around on the machine. So anyways, I'll dive into setup 1 here. And because I don't have a tool changer, I've separated them into folders. Each folder is a tool. So folder 1 is like it's a 3/8 inch end mill, and I have to keep everything small and light, right? Because if I'm gonna attempt to do this on a router and I don't have a rigid setup, everything on here is gonna vibrate and chatter. So I gotta keep my like tool pressure real low. So I'm gonna stick with small tools, and also because my spindle can only go down to 10,000 RPMs, I can't run a big tool because then my my surface footage is gonna creep up too high. And I won't be able to keep up. I'm not going to be able to shove the cutter through the material fast enough. So I got to find a balance between that. And what was nice is somebody pointed out, take a look at this off screen first. Okay. So on Helical's website, they have this machining advisor. Oh, get rid of my camera here. Okay, they have this machining advisor pro, and it's a free tool. And let's see if I'm logged in here. Password. There you go. We'll fix that. Okay, so anyways, you can look up your feeds and speeds on this nice handy little tool. It's not quite as complete as the tool that you get with oh, whatchamacallit, invalid password. Not quite as complete as the one that you get with GWizard, because GWizard will actually tell you like all your tool deflection and everything. Horsepower requirement, very detailed, and it's like $80 a year. This one's free, and I kind of found it to be handy. So if we look up a tool from Helical, right? So if or Helical, whatever. Anyways, okay, so I'm into their products, and I look for an aluminum, let's say rougher, and oh, actually, this reduced neck one looks interesting. Okay, so say like I think that's gonna work for my job pretty good, because I have to go down like a 1.5 inches, and this thing has a reduced neck, so you see the little like shoulder right there. That little shoulder means that this shaft isn't going to be rubbing when I'm in some really deep pockets, so that could be nice. So I'm looking at 3/8, and if I have to go 1.5 inches, let's see, that's an 1.125 inch reach. Let's go up to this longer tool. That'll get me my 1.5 inches. So then I can look at these numbers here. Let's look at the coated one. Again, I don't have flood coolant or anything like that, so let's look at a coated cutter. And I can take this tool number, copy it, and come over here, paste it in, and then I can start filling this out. So I'm in 6061 T6 hardness, and I'm milling, and I'm using high efficiency milling. That's the all the adaptive tool paths in Fusion, right? So if you see in Fusion, I'm using like adaptive clearing, hog these out. That's going to be easier on my machine. I'm going to choose the weakest spindle that they have here, which is probably this BT30 and an ER collet. It's even warning me that that's not a super rigid setup. Okay, and then my work holding is not great, so I'm going to pull that slider all the way down. And in the recommendations here, also I'm going to bring the speed down towards increased tool life, and I'm going to bring the feed over to less tool deflection, right? So that should be like the gentlest settings on my machine. And now I can kind of fill out over on the side here how much cutter I can engage, and I can look over here at the recommendations. We've got the surface speed that I'm not going to worry about too much. It's going to keep me this little, you know, tool, this little, whatever you call it, this little app that they wrote is going to keep me within an acceptable range for the material I've picked. What I need to look at is the spindle speed and the feed per minute. I need to make sure that both of those my machine is capable of. And the MRR, that's the material removal rate, right? This is 7 inches a minute, 7 cubic inches a minute. That is going to be too high for my machine, right? So my machine's probably only capable of like 1 inch a minute. So that I'm going to keep an eye on. I'm going to make my adjustments over here to how much material we're engaging with the cutter. So you can see I can pull these sliders around and change how much material we're going to engage, and it's going to update over here and tell me what the recommended speed and feed are and how much material I'm removing. And so come in and say that we're going to only engage like 20 or 30% of that tool, and you can see what happens to the speed and feed as I adjust those. Now my max speed on my spindle is 23,000 RPMs, and I can feed up to 200 inches a minute. So at a setting like this, I'm getting really close to the upper limit of my machine. It's recommending 22,000 and 191, and the material removal is way too high. But what I would do is bring the depth of cut down, and you can see the material removal rate start to drop. Now we're getting closer to a range that my machine would be happy with. Let's drop it a little bit more. Okay, so something like that might work, right? So we've got this 3/8 tool, and we're engaging about 30% of the radius of the tool, and we're going 0.18 deep into our material, and it's going to kick back that they recommend 10,700 RPMs and 119 feet per minute, right? So that's within reason for my router. The material removal rate is 2.4, so still removing a lot of material. I think that still is probably on the high side for what my machine would be capable of. I think that comes in with the feeding 3,000ths per tooth is probably aggressive, and it's probably gonna chatter in my machine because, like I said, it's just not rigid enough for doing this. It was built for cutting wood and plastic, not for cutting metal. But I think with all the tools that are available to you on the web in 2018, that it's possible to kind of stretch the capability of these machines into territory that normally you wouldn't dare go. So let's see, taking a look at my first setup here. I ordered the extrusion of aluminum. It's a 1.5 by 5-inch bar, and this like yellow overlay here is the piece of bar, right? So I have that inputted into Fusion, so Fusion knows how big my stock is, and I cut these on the bandsaw to 12 inches. And my box, if you come in and take a look at the corner, see I've got a little bit of material all the way around that needs to be taken away. So this timer enclosure fits inside of the stock. If I can kind of line that up. Same thing with the top and the bottom. Yeah. Okay, so there's material all the way around. So we're going to be left with machined surfaces on every side. Like I said, here's our chunk here. And it's actually pretty heavy. So that's the side from the bandsaw there. So I've got a stack of these things, and we've got parts to make 5 of these timers. And I'm going to try one, and if it fails, then I'm just going to be kind of stuck waiting to get some time on the real big boy mill. Okay. First things first, normally you would face the top of your material, I believe. I'm not really a machinist when it comes to working with metal. It's always been wood and plastic, and all the metal parts that I've ever dealt with are always sent out to other machine shops, but I'll give this a try. Rather than facing the top of the whole entire bar off, because I don't have a big giant face mill and I'm just working with tiny little cutters, what I figured I would do first is walk around the outside and only face the parts that are going to be showing on our final part, right? So I'm not facing this whole entire thing down. I'm kind of walking around and cleaning up just the top faces that I need to, if that makes sense, right? I don't know if that is better or worse, because I don't know, we're only peeling off 50,000ths, right? And I have to go very slow. And so facing this is going to take forever. So I'm going to only face off the parts I need to, and then the second operation, I'm going around the outside, clean up the outside walls, and okay, then I do this pocket, right? So rather than doing this operation twice in my head, right? So rather than facing it, the whole entire thing, then cutting this pocket, I figure I can just cut the pocket. And that'll save me a whole lot of time running back and forth across this part. I don't know if that's going to come back to bite me later, but it seems like a good idea right now. So anyway, let me dive into edit this. Okay. So the first thing I do is kind of pick my tool and I come over here. Oh, this stuff is all buried under my chat. Yeah, there we go. Okay. So I come in and I select my tool. And what's kind of nice is that they give you a whole bunch of built-in, a whole bunch of built-in stuff from a couple vendors. And so I came in and grabbed some of the like Tormach cutters. They give you a whole library of tools that would come with your Tormach mill if you ordered one. And so that's what I did. I grabbed a 3/8 inch end mill from that library, and then I modified it. So then I came in and hit edit tool, and I filled it out with the information from the Helical website. Right, so I was looking at this tool here, and I came over here and I filled out the description and the part number for that cutter, and then put in the dimensions and the fact that it has a shoulder on it and stuff. So that's all been put in there. 3 flutes, carbide, no through coolant. And then I come over to my feeds and speeds, and we threw some numbers at it. So we're like 10,800 RPM. Gives us like a surface speed of, about 1,000 feet per minute. And then we're cutting at 120 inches a minute. And let's see if that matches kind of what I just set up here. Yeah, so that matches 10,785 and 119 is kind of what the it's kind of what this little configurator is telling me. So I'm going to trust it for now until we fail. So, okay, I don't want to keep any modification. This rougher has a little bit of a corner radius on there, so I put that in there. All right, and you can see it's all set up. It's all filled out in here. And if you wanted to come in here and override anything just for this operation, you do that right there. Geometry. I come in and I select this contour here for my pocket, and then I also want to select the outside of the stock, so I've checked this stock contours box. And that gives me the geometry of the whole entire piece of stock, because I've got some material that I got to take off. Here's your heights, right? Clearance height, retract height, top height, bottom height. So top height and bottom height, that's where the machine is going to be doing the work. So top height is the top of my stock, right? So you see I've got stock top selected. Bottom height, because I'm facing, is going to be top of the model. And you can see these like 2 blue lines here, just 50 thousandths that we're peeling off. And retract and clearance, right, that's your safety, right? The tool is going to pull up to the retract height every time it's like done with a pass, and at like the beginning and the end of the operation, it's going to go up to the clearance height. So your clearance height is like, okay, this height is safe, that I'm not going to hit like the edge of the vise sticking up or something like that. That's what your clearance is. And your retract is going to be high enough so that I'm not going to hit anything, inside of my part. Like if there was an island like this up here on the top of my model, you'd want to make sure your retracts were going up over the top of that. Okay, over to passes. Here's where I'm putting in how much material we're removing in every pass. So over in this little machining advisor, it's telling me my like step over is 1125 and my depth is 0.18. Right, so I've come over here and filled out an optimal load. So the optimal engagement is going to be that 1125. And my depth of cut is not set up because we're only taking 50 thousandths off. Okay. I've enabled both way machining, which means it's going to help save me some time by doing a little bit of conventional milling, and we'll see how that goes. But I've lowered the amount of material that it's removing when it's milling conventionally. But what that should do is kind of save me a whole bunch of time in like rapid travel. My machine rapids at 300 inches a minute, so it's not like a big boy machine that rapids at like 2000. So I mean, that's almost cutting speed, my rapid. So I'm going to save time by cutting in both directions, both when I'm climbing and when I'm going back. Stock to leave. Putting in a negative number here. And what that means is that I'm going to go past this edge here. This tool has a corner radius on it. And so if I have this set to 0, my cutter is going to stop exactly on that line, and the corner radius of the tool is going to leave a little lip. And so I've put in a negative number here so that it knows to go 50 thou past that line. And that's going to kind of leave me with a clean edge when I do the second operation. It's going to make sure that my corner radius is out of the way. And that's about it. Linking, I don't really have to worry about here. So every time you make a change, it kind of regenerates. And there you go. That's the path it's going to take. Here you can see the kind of the lead into the material, and it's going to go around that part like 2 times. And then it's going to come over to this little face, and it's going to go back and forth and hog some of that machine out. Hog some of this material out. And so whenever you want to see how you're doing, you can hit this little simulate button up here, and I'll show the stock. Okay, so that is my material. Hit play. See what's going to happen here. This guy's just going to walk around there, and it's taking a nice tiny little bite, which hopefully my machine is strong enough to do this without making a huge mess out of this part. And here you see it kind of walks back and forth, cleans up that face. Okay, that shouldn't be too bad. Okay, and we go into our second operation. This is a contour where we're going to walk around the outside of the part to clean up the walls and bring this outside of this box to its final dimensions here. You see I've got like 2 passes going on here, and all that is like taking a roughing pass where I get rid of most of the material, and then I step over just a little bit more for a finish pass, and hopefully most of the tool deflection is gone for the finish pass, and I get a nice surface on it. And you can see I'm putting a lot of step downs in here, right? So even though like this tool is capable of going very deep and doing this in like 2 passes, I don't want to do that because I don't think my machine can handle it. So I'm just going to take small bites and work my way down a little bit at a time, and hopefully we have some success that way. And we can kind of simulate that action there. So you can see I'm deeper than before in the first operation, but I'm taking very little material off. I don't know if that's going to be bad because of like chip thinning. I don't have too much experience with, like I said. Don't have a ton of experience in metal. We'll see how this goes. There's my 2 passes. Get around. Then it's going to step down, work its way around again. Kind of speed. Goes around twice, then steps down. Goes around twice. Steps down. Goes around twice. Who knows? Who knows what we'll end up with. Probably a big chattery mess. That's what I'm anticipating. Okay. After I'm done with that outside, then I come in and I'm doing this pocket here. So, and again, this is like another high-speed machining strategy. This is 2D adaptive clearing. And I'm just going down to the shoulder that our like plexiglass window sits. And let's simulate that. You can see it's going to helix down into the material. So it's only taking a little bit at a time as it plunges down. I'm not going to try to drive that 3/8 inch end mill straight down. That would probably end up just pulling my Z-axis right down. Because again, it's like only a stepper motor machine. And if it loses steps, that's the end of it. And if I try to plunge that end mill, it's basically going to try to like drill into the material, and it'll pull my spindle right down in. So a nice shallow helix there to get into the material, and then this guy's just going to walk around and take that small little bite, that like 30% step over. Get that centered up on the screen a little bit. So around and around it goes. This is nice because I'm always taking material off. I'm not doing any traveling. But then once it hits the wall, then it's going to have to start to pick up and move around. Okay, there's flat spots are starting to develop. So, okay, there it's going to stay in the corner. Nope. It's going to hop around. I'm not sure what causes it to put those extra travels in there, but just something I'm going to have to live with here. See, it should just finish that corner there. I don't know why it travels outside of the corner and then comes back to it later. But you can see that it's engaging the material in both directions. Right, hopefully that saves me a little time. It's both climbing and doing conventional. Yep, and it's just going to walk its way over. And you can look up just how it's doing. Bring this window up where we can see it. Okay. Statistics. Machining time, 7 minutes, 14 seconds. It's operation. So, not too bad. It's fast enough that I can sit there and watch it. When you start getting up to, half an hour, that's when it's tough to sit there and just watch that machine go. Okay, so that's going to take care of our first pocket, get us down to this shoulder. After that's done, this is a finish pass. Yes. So I've selected a contour, and all that's going to do is just run around the edge and clean up the 2D adaptive. I can simulate that real quick. So all it does is run around the perimeter of that pocket to give me a nice smooth wall. One thing I do for that to try to get like a good finish here is on my material. Okay, stock to leave. See that? Okay, stock to leave. Nothing on the wall. I'm going all the way to the wall, but I'm leaving one thou on the floor, and that's just gonna let the tool be slightly off the floor, and that way I'm only cutting the wall and not trying to cut the wall and the floor at the same time. I don't know. It seems like that should go easier on my machine. The tool's got a corner radius, so you won't even be able to see that I did that. Here's the big operation here. So adaptive clearing. This time it's 3D adaptive clearing because I've got some islands down in here, right? Our standoffs for our Raspberry Pi. So here's the major operation that's gonna remove most of the material. Same feeds and speeds as before. We're still working with the same tool, so that's all gonna stay the same. For my geometry, I'm selecting the inside pocket here, and I believe I had to contain it as well in order to keep it from trying to machine outside of the box. Yeah, so machine boundary. I also selected this contour as a boundary for the tool not to go outside of. That way it didn't try to bore this hole over here or anything like that. And heights, passes, again the same load on the tool. My step down is 200. I've got flat area detection checked, and that means it's going to put like an extra pass in at the height of these standoffs, right? So if this standoff doesn't happen to be like exactly divisible down to like 0.2 to get to this flat area detection puts an extra depth pass in there at that exact height. So that's kind of nice. And not leaving any stock. We're taking it all the way. I'm not going to bother like finishing the inside of this thing. I did finishing on the upper pocket because the plexiglass has to sit in there nice. But down here, I don't really care what it looks like. So we're just going to run it. And so, because I was in there touching things, it's going to kind of rebuild the tool path here. Just got to wait for the machine to catch up with me. This is nice, gives you a little percentage of how far it is. There it goes, starting to build the path. Okay, there you can see some of the weird things it does in order to get around those little islands here. But the reason for using these newer tool paths is, again, it's a nice even load on the machine. The cutter doesn't get buried in corners where all of a sudden you see these huge power spikes that you need. With a more delicate machine, you can't be burying that cutter into a corner. So these high-speed adaptive paths work well for making these like softer hobby machines work. But let's see if we simulate what this guy's gonna look like. Speed that up. So this is gonna be the boring part of cutting this, because this is a 36-minute operation, so it's not going to be something I'm going to want to walk away from. So I'm going to be stuck there watching this thing go to town for a half an hour. It is cool. I've got mist lubrication on the machine, so I'm hoping with a nice mist on the tooltip that it's not going to be too hard on my machine. Around those little islands there. That's it. I'm going to be left with that in the corner. And I thought about doing a tool change and going in there and cleaning it up, but I really don't think that affects anything for what we're doing. So I'm going to leave them. Okay, last operation while this tool is loaded in the machine is going to be this helical bore. And that's going to be to chase that thing out. So all that's doing is taking, real light step downs. It's going to perform
William
this
Hoff,
helix.
you will be busy clearing chips.
Yeah, that's true, right? I'm going to be sitting there and blowing all the chips out of this box. Good point. I'll have plenty to do. So, okay, anyways, my helical bore, I'm going to poke out. You can see there. I'm just going to poke out the bottom a little bit. That way I don't have to try to locate this on the second operation when I flip this upside down. I don't want to have to try to find that on my machine. I don't have any way to really precisely locate this thing. It's going to be up against stops and stuff like that. So I'm just going to go all the way through in this operation. And like we were looking at that tool that has that reduced shank, right? So I should be able to plow down to the bottom and all the way through there without too much fuss. So anyway, so that's my first folder. That's my 3/8 inch end mill. Next, what I'll have to do is I'll have to do a tool change on the machine. And then I'm going to put a little spot drill in there. And I'm going to come in and spot the top of those standoffs so that we can drill and tap those later. That way they'll be precisely located. And while I have a spot drill in there, what I can do what I can do after this is to do chamfer these edges so that we're not left with these razor sharp edges with burrs. I'll take this spot drill, same spot drill, and we'll run around the part and chamfer it. So I'm selecting a chamfer operation here. And let's see, our spindle speed, 10,000 RPM. That should probably be higher. I'm going to throw that at 15,000 RPM. It gets me up to about 1,000 feet per minute. I'm not sure where it's taking that measurement from. 1,000, 15,000. I'm going to suspect that surface speed is out at the 1/4 inch radius. As you get closer to the tip of this tool, the surface speed is going to go down, which is going to kind of, if this thing starts doing goofy things like rubbing and stuff like that, it's gonna make a mess, and the aluminum's going to start to get like stuck to the cutter. We're going to go slow because we're going to maybe try to cut about at the halfway point of this thing. Leave that where it is. Our geometry. Okay, so let's select what we're going to chamfer. Walk around that. And walk around that. I'm going to save the inner pocket for a second operation because I want that chamfer to be a different size. Okay, our heights. Probably good. Passes. This should be just one pass. Chamfer width. Let's say like a 30 thou. Tip offset. See what 20 does. Ooh, what's the difference between chamfer clearance and tip offset? Don't know. I think if you hover over these windows, they tell you. Tip offset. Okay, that's what I thought it was. What is chamfer clearance? Ah, chamfer clearance is to make sure you don't collide into it. Ooh, this is nice because Mastercam, I have to do that by hand. That is kind of nice. All right, let's do this. Go. That looks pretty good. I'm going to simulate, but I'm going to kind of stop it and turn off my stock and take a look at where we're engaging the tool there. Okay. I could be higher up on the tool, I think. I want to be in this upper half. I'm not going to hit anything, so I think that's fine. So let's go back in and edit our tip offset there. And let's go back to the default that it was telling me. 40. All right, let's simulate it again. All this cool stuff. You don't even have to do any math anymore, right? Stop it. There you go. Now we're about halfway up that tool. So I'll live with that. Okay, so now I want to do one more chamfer, and this time we're going to do the inside. And passes. Okay, so this I want to be a much lighter chamfer. And the tip offset, well, we just want to make sure that we don't end up getting the tip down to that shoulder there. I'm just going to back off to 30, even though I think we're still plenty far enough away from it. And we can hit that simulate button and run it around. Stop. And let's see. Marty, where's the X-ray button? Visual style wireframe. Okay. Oh, geez, we're still a mile away from it. Anyways, well, that'll work. We're gonna distribute the wear on the cutter by putting those two different values in there. How's that sound? Sound good? Cool. All right. So then that these two operations should go into my folder 2. And this folder is going to be my spot drill operations, right? So it has my little spot, my 2 chamfers, and then it's done. Okay, so let's say I'm ready to output setup number 1. So this thing goes on my router table like that. And I don't have a tool changer, so I need to post these out to my machine as 2 separate programs. I'm going to run the first program with the 3/8" end mill. When that program is done, I'll change my tooling to the spot drill, touch off, and then run the second program. So by putting into a folder, I can just click on this folder and process just the one folder. Okay. I have downloaded the post processor for my machine. Nice thing about Fusion 360 is that there's a lot of people developing for it. And so you can come in here and there is quite the list of machine posts right right off the bat built in. The controller that I have was built in to Fusion, but I went out to Fusion's website to look if they had any more detailed posts, and they did. They had a specifically a post for my machine. I don't see it. Why? Oh, because I was playing on the other computer. Anyways. Okay, so I have a WinCNC controller on that machine. I know it's embarrassing, but that's what I got. Okay. I have to kind of take a look at here. These, when I selected WinCNC, it filled these out with some generic values for that controller, and most of them are good except for I don't have a tool changer, so I just have to come in here and say no tool changer. All right, I can give my program a name, and let's say like this is, I'm just gonna call it 375 so that I know that it's the 3/8" cutter, and post. Okay, gonna ask me where I want to save it. I'll just save it in our little streaming folder here, and it's gonna open up the code in just like a text editor once it's done posting, and I can kind of take a look at it and make sure everything looks good. And if everything looks good, then I put it on a thumb drive and transfer it over to the machine. So I think next week I will have either a timer enclosure or a really cool fail video. What did it say? Why does it say restart? That thing wrote a file into the folder here. It did write a file, it just didn't open the text editor. Okay, there's my G code for my machine. All 5,000 lines of it, however many we got here. But I can see that this post is going out for decimal places, which my machine will be very happy with, as we figured out with Lone Star. Something in the back of my mind says that my machine doesn't like these brackets on the comments, but we'll see if I load it up if it yells at me or not. But anyways, that's good. Like inches, I don't remember, G20. What's that gonna do? Clear out my work offsets and then go to town. I'm kind of reading it right now, and I'm looking for this thing to turn my spindle on. Don't see the M3 to turn my spindle on. Interesting. What about at the bottom? Nope, and no M5 to turn my spindle off. Okay, so I know that that post is no good. So I actually would have to go grab the Shop Saber post and use that instead of the generic WinCNC post that was built into Fusion 360. So actually, I don't do most of my work on my streaming computer. Most of my work is done on my newer computer. So that's where the post is installed. I'll have to install it over here too. operations from this PC as well. But anyhow, that does not affect us until we go over to the shop and start machining. So, okay, so anyways, so we post that, and then we come down to folder 2. This is our spot drill. Again, post-process it. It's just giving me an error because I need to like rebuild some of the operations because I've made changes to the geometry. Anyway, so I go in here, instead of WinCNC, I would choose my Shop Saber. I just have to download the file to this PC as well. And give it a name and post it. And after that, we start the other setup. Those 2 programs are done. I'm going to flip my part upside down and grab onto it again. And we're going to face this off because this bottom is still raw material, right? It's still the raw extrusion. So we have to face this thing off and then start drilling all these holes and tapping them. So what I've done here is our first folder is the facing operation. I've loaded up that 3/8 inch tool again, and this time I don't have any option. I've just got to walk back and forth for a few minutes. Let's see how long these facing operations take. Simulate. So we've got just over 5 minutes of facing. That's not too bad. After she's done facing, it's going to do a contour. Okay, so what this contour is, there's going to be a little bit of a little brim left over, because when we machine to the other side, we can't go all the way down because I'm holding on to it with a vise. So now that we've flipped it over and we're holding on to it with the vise down here, this contour here is going to clean up that leftover brim. All right. So what's really important here is that I am in the correct spot. I've either indicated it or I've like, bumped up against a stop so that I can be repeatable and that these 2 operations are gonna line up, which they probably won't, knowing me. You're gonna see a little bit of a line, maybe a lot of a line. We'll see. You might even see 2 rectangles shifted over. Who knows? Anyways, that's what a real generous corner radius is for. Okay, so that's my first operation, or my first tool, and then I gotta change tools, and I'm grabbing that spot drill again, and I am going around and chamfering the edge, and chamfering the hole, and then I get to put that tool away and get another tool out. This is kind of where I left off. I've gone down to an 1/8 inch end mill, and what I'm doing here is, you know what, Marty, we edited these holes, so we got to reselect this. Okay, so these holes need to have a flat bottom, right? Because I don't want them to come through the inside of our box. I want this box to remain waterproof. So we're gonna mill these things out instead of drilling them, because the drill's gonna have a point, and that point's gonna end up coming through. And we only have 6 millimeters of material to work with, so I'm gonna go in 5 millimeters with an end mill that give me a flat bottom hole, right? So I'm gonna walk around and select my holes. And Marty, I think I was asking you, where is the mask on arc? So they don't have to do this. Silly. All right. Good thing there's only 15 holes. Okay, I've selected my faces and my heights. They've automatically filled out. Top height, hole top. Bottom height, hole bottom. This is kind of nice with the software. It just kind of fills all this stuff out for you. And the helical bore, you put your pitch right here, and that is threading type operation. Anyways, this pitch is how deep it's going to go each turn or each revolution. All right, so my little 1/8 inch cutter is going to go around and bore out this like 202 hole, which is the minor diameter of our 1/4-20 tap. After it's done going around and doing that, which I just show you how it wiggles its way in there. Right, so after it's done doing that, then I'm going to use this thread milling operation. I can't get a tap down in there. I can't tap with my machine, but what I can do is mill with my machine. So I use this tool, which is called a thread mill. You can see it's got a single point on it, so it's only cutting like one thread at a time. It's kind of going to do the same thing. It's going to do a helix inside of that hole, but this time that helix is your 20 pitch on your 1/4-20 hole, right? So every revolution is going to go up 1/20th of an inch, or 50 thousandths. So if I edit this tool here, I've selected my thread mill, right? This thread mill here. You have to select a thread mill that's going to fit in the hole, and so I'm going to use the biggest thread mill that I can get into that hole, and that happens to be a 180. All right, and I'm just going to leave the recommended defaults here, and in our passes, I have to put in my thread pitch because I want
William
a
Hoth
1/4-20.
under geometry hole mode diameter range.
Let's see, under geometry hole mode diameter range. Oh, for I gotcha. We're doing the selecting all the holes at the same time. Yeah, that will be nice when I do that. For geometry hole mode diameter range. Okay, we'll check that out. Okay, this is what I didn't like about this thread milling in Fusion. To me, it should be able to pull these values in based on the fact that this is a 1/4-20.
William Hoth, yes.
1B hole, but it doesn't. It pulls this in as like 0, and the tool doesn't even engage the walls of the hole. And I'm not sure why I have to like go in here and look numbers up. To me, that's not very 2018. So anyways, I gotta get the calculator out and figure out how much offset there is between the minimum diameter and the major diameter, and then put that in here. I think that's silly that I have to do that. But anyways, put that number in there, and then step overs, I'm just going to take 2 passes at doing it, and hopefully that'll kind of take care of the tool deflection and stuff.
Cram Nitram 1, is it because the threads are not modeled?
I don't know, Marty. I tried both ways. I did it with the threads modeled, but then the hole wasn't the minor diameter. I don't know. Got me. Maybe I'll try that again. But it seems like it's missing something that should make this real easy. Like, just select the operation, and the defaults are good to go unless you need to do something special, like take multiple passes or something. Anyways, why did we fail? Oh, we failed because, again, we're missing our faces. Okay, so okay. Where's this mask on arc nonsense?
Cram Nitram 1. I've never used a thread mill, so I'm not sure.
Is there a context menu I'm missing? Ooh. That. Interface selection. No, that's not letting me pull. I don't know. I still don't know how to get all these arcs selected in one shot. Somebody's gonna have to hold my hand. Okay. Will that regenerate okay? Uh-oh. Okay. Okay, cool. You can see the two helixes. Oh, you know what else is not a default, which is super dangerous? In Fusion, the lead in and lead out by default crash the cutter into the side of the hole. That to me is also something that is crazy. So by default, this lead to center is not checked. And you can see that the cutter enters off to the side a little bit. And with this minor diameter, the cutter hits the walls. So you have to make sure that you check lead in, lead out to the center. That should be a default, and I don't understand why that's not a default. Anyhow, I guess it wouldn't matter on larger holes. Okay, yeah, so that is not a default because if your hole is larger, like let's say if you're doing a 1-inch hole, you'd want to be over towards the wall because otherwise you'd be wasting a little bit of time, but I don't know. Either it should kind of filter by hole size or something. Not catching that checkbox is, yeah, a fun way to break a tool. So anyways, oh, I guess we can kind of simulate this thing. So I'll slow that down. So that guy's going to come in. And that thing is red, which is generally a warning. There it goes. You see it just spirals into that hole. Oh, I think it's giving me a warning because it hasn't detected that I've already cleaned that hole out. That's number 2. Then we wrap it over to our next hole. Yeah, it thinks that there's a collision because I haven't cleaned that hole out yet. But I have, we cleaned that hole out with that 1/8 inch. So there's that first pass, and then plunge down, take our second pass. I don't know, hopefully we have a 1/4-20 blind hole with a flat bottom.
Smarky FPV little perverted.
And hopefully we get like, I don't know, about 3 turns on the screw. And it seems like...
Cram Nitram 1. Do you have rest machining on?
There's no like rest machine thread milling. Checkbox for that here. No, I think what it is that I'm simulating in the middle of the, you know, flow here, whatever you want to call it. I'm sure if I simulated both of these, it probably wouldn't give me that. Let's look at that theory. So if I simulate both operations, there's my helical bore. Pink, 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 pink. Okay. Yeah, my tool's not turning red, so it's not detecting a collision anymore. You also see it's not coming all the way out. I also have not included the facing operation. So yeah. Oh, the other thing I could not figure out in Fusion how to use that tool to chamfer my hole. Would not allow me to do it. I'd have to use like a generic end mill, even though I know that I'm still using that thread mill, which I'm not crazy about. But I could go and chamfer those holes with that thing. That would save me a tool change. So anyway, yeah, so that's that operation. Okay, so we're almost done at that point. All we have to do is our third setup, which we stand this thing up in our vise and clear that out. So let's walk through that. I need a new setup, and I'm gonna have to tell the machine where we are located. So I'm going to put my origin in the upper left hand corner, and I'm not going to use the stock because the stock is now all gone, so I'm going to use model box point. Select that corner, and Z is my spindle, so that is correct. And on my machine, that is my XY direction. So I just have to know that's how I need to load my part. Not like that, like that. Okay, so we're machining in like positive X and negative Y. So what's this do? Mode. Oh. Okay, stock. We don't need stock, so what can I do? Box? Oh, perfect. Kind of. No, that's not perfect because thinks that hole's already there. Fixed size box. Nope, that's not what I want. Relative size box with no additional stock. Perfect. There we go. Now there's still stock in that hole. Okay. Okay, that's my third setup. There's our origin. That's where I need to touch off to. And now we just start clearing these holes here. I'm gonna say I drill and tap this by hand, and we'll just do our adaptive clearing with that 3/8 inch end mill, and then spot drill to chamfer it and give me my locations. So I've selected my contour here for the operation that we want to remove. The stock top is correct for the top. However, our bottom height needs to be in here. That's how deep we're going. I needed that clearance for that part to fit in there. And our passes, so our optimal load was that 0.1125. Oop, our tool. Select the tool first. Where's our rougher? There it is. Okay, so there's our long reach rougher. And our optimal load, good. Multiple depths. We're not going to take this all in one shot. We're going to step down 0.2 at a time. And we're not leaving any stock. We're going all the way. And there it is. I mean, this is quick and very visual. I'm really enjoying setting the machine up in Fusion. I gotta tell you, it's nice. Missing a couple things that, like some overrides and stuff that are handy, but isn't too bad. So it's going to helix into the material, and then looks like it just does like 2 passes to get over. Kind of simulate this real quick. Helix down, scooch over, helix down, and then over. And we're looking at 2 minute and a half. So totally acceptable. We're machining a whole bunch of air, but what are we saving? 30 seconds? No big deal. All right. We've cleared out that hole. Last thing we do, we're just going to grab our drill and change our tool. We're back to that spot drill. And okay, so spot drill, hole mode, diameter range. Okay. So in the drilling tool paths, you can filter by arc. Just did not let me do that in whatever operation I was using, which was that helical bore. Didn't let me do that. So if I do diameter range, containment boundary, that containment boundary. Oh, oh. That's something that I like better in Mastercam. It's just I can click on the first arc and then draw a box around the rest of them. That makes sense, and that's super easy. I'm just going to select my 4 faces here. Okay, so all I'm looking to do is, I guess kind of kill 2 birds with 1 stone. Just go deep enough to put a chamfer on the finished hole, while also like allowing me to locate that hole so I can drill it out and tap it by hand. Bench. So my height, that's all I gotta do, not go to hole bottom, but just do an offset. So stock top, -0.1. This is nice because you get visual feedback. Say that that's a little too deep. That looks good. Okay, that's going to spot that in. Right, nice and easy. And then last, chamfer my edge. And I only want like 20. And I'm going to do a different tip offset and distribute the wear on that. So I can simulate this whole setup from beginning to end. Crank that speed up. Let's see, can I hide the... Allow me to hide the model here? So I can kind of see those chamfers there. Cool. That's it. So then I would just separate these 2 tools into folders. Right, so add new folder and add new folder. Okay, so those are my 2 tool changes, and I can post those out. that'd be it. Be programming our little timer box. So cool. What what's the decision on the King of Hearts? What electronics should we build this guy up with? All right, we've kind of. Oh, before you know what? Before we get too far, I got something else we got. Let me look and find it. Okay, so Ready Made has given us a little help here. As you know, Ready Made is our main sponsor for the bando, so if you head over to Ready Made's website, RMRC Bando 2018, put that coupon code in and take 5% off of your order over there with those guys. And I know I would appreciate anybody helping out the people that help me build races. So if you're ordering anything from Ready Made, go check it out. We got a coupon code for you guys, RMRC Bando 2018. All right, so that's gonna help us in Buffalo Multi-Rotor build more races, because they have been our #1 sponsor and the biggest help to me putting together all the junk that I got in that race trailer that we've been taking around. And we've got our first major race coming up real soon at Maker Faire. So the weekend of the 12th, right? So that's just like 2 weeks away now. That Saturday, we're gonna have the tiny whoop track inside, and we're gonna have the full-size track outside on the football field. And I'm gonna need a little bit of help from you guys so that we can keep both of those things running. I'm gonna kind of concentrate on the tiny whoop track in the morning, and then transition into the full-size stuff in the evening, and hopefully kind of engage the younger crowd with the tiny whoops, and kind of get everybody's going to be drawn to the full-size stuff, because we know how loud that stuff is, but they're not going to be able to get as close to the full-size stuff as they can with the tiny whoop track.
FPV 2 weeks.
So my main focus is the small drones, and it's because of how approachable and how interactive the people can be with the small stuff, and nobody's going to get hurt with the Inductrix, short of like having one stuck in their hair. So yeah, Smarky, I'm looking at you. Want to run the tiny whoop track? I'm hoping that we can move the spring series final race to Maker Faire. And I guess I have to put up a poll in the Facebook group to make sure everybody can do Saturday instead of Sunday. And that would be
Matt Fender, where is
huge for me. Oh, okay. So Maker Faire this year is going to be up in, well, I say Amherst. I guess technically it's Snyder, but it's just off of Main Street by the 290 at the Park School of Buffalo. So that's like a K through 12 school, but it's set up more like a college campus, separate buildings and I forget, it's like 60 acres or something like that. So it's spread out, and we've got the big athletic field, and it's got a berm around it. So I think we're protected. I'm gonna just set up the ropes and stuff like that to keep the keep the crowd back from the 5-inch stuff, and hopefully everybody can kind of be along the berm and watching like a multi-GP qualifier with the 5-inch stuff in the evening. But for most of the day, like I'll be on the baby bando track in the morning, and then I'll come out to the main track, to the big track, in the evening. That's my plan. I need to kind of pull together a like second crew to man the track that I'm not at, and we can kind of like swap tracks. So I don't know. Hopefully that's a plan. My cat is telling me that it is time to go to bed. He's come looking for me. He's getting hair all over my desk. Thank you. Yes, thank you. Good kitty. Okay, so anyways, we've got to decide what electronics are going to go into the King of Hearts, and I guess I'll also pull in the Furious FPV board. The other board that I wanted to look at was that butter board that runs the Butterflight with the dual, the F3 and the F4 chips on it. What is it? Helio? Yeah. So I saw that on Ready-Made's website, and so I think I've got to order that as well. So it'll be between the Furious, Helio, the HGL,
Smarky FPV. Let's
Hobby
see if
Wing.
we can get the Erie Paw and Rochester group.
Oh, is the Helio
Matt Fender,
bigger?
That's 30x20.
Okay.
Matt Fender 30x30.
Darn. I like the idea of having the two separate chips. Oh well. Okay, so we gotta start. We gotta stay in the tiny stuff. No big deal. Man, I was hoping to get to both of these things tonight, but I don't think we'll start. We'll build this guy on the next stream. And you guys, I don't know. You saw what I have here. I've got the Hobby Wing set up, the HGLRC set up. Got that Speedix 4-in-1. We've got the Furious FPV. I'll let you guys decide what we're gonna put in this thing, and then we'll do all the assembly and soldering on the next live stream, and hopefully I'll have some footage of the of how this thing is going on the router. And I guess, I don't know, for some of you guys that have been around me in the past week or so, I am building a new studio in order to get everything under one roof again, because I have stuff spread all over Erie County, and it's driving me totally bonkers because I'm a scatterbrain and I'm forgetful. And when I forget, I've got this tool's over in Hamburg, and that tool's in Boston, and this thing's here, that thing is driving me crazy. So I'm trying to pull everything back under one roof. So I'm building myself a new studio, and 2 floors, CNC's on the first floor, and office on the second floor, with an area so that I can shoot all my like live streams and stuff like that. So I don't know, hopefully that comes together this summer. So we already started tearing into it, and we're working. I know I'm working as fast as I can,
Matt
because
Fender,
these
do
races
you
are
still
coming
have
up
more
fast.
X1300 and SIXS? I need to buy a few more.
I've got plenty of
shafts.
Yep, plenty of 1306s. I shouldn't say plenty. I probably have a dozen. Probably have a dozen of them. So I'll take care of that. If I have the trailer with me, Fender, I have them. And otherwise, just give me a heads up. On Sunday, I've been bringing the trailer to the track on Sunday. So yeah, if you came out on Sunday, I'd have it. And what's this Saturday? This Saturday, you guys are going up to Canada. That's right. I might go up to Canada too. Although I want to stay back here because I got to keep moving forwards with my new office. Otherwise, it's just not going to get done. So anyways, I think that's about it for tonight. So yeah, if you have anything on your list of things that you need to get for the summer, yeah, visit Ready Made because they're helping us out big time. Get ready for the wing race, which is just
Matt
2 weeks
Fender,
after
I
the
think
Bando.
it's just me and JT from our group.
You and JT, is Quest going up there too? Oh yeah, Smarky. When are you leaving, Smarky? You leaving tomorrow for your vacation?
Matt Fender, I thought he said no.
Quest said no. I hope Quest gets enough practice in for the regionals. It's one thing to do it in the simulator, right? A whole nother thing to do it in real life. It's going to be quite the battle this summer. Oh, not that I want to be on here too much longer, but I don't know. I brought the Titan over to Fusion to take a gander at it. So I exported the solid model from SolidWorks, and I'm pushing and pulling on it in the sculpting
Smarky
workspace.
TV Saturday morning.
There we go. Saturday morning, you're out? Okay. Keep that in mind. When you coming back, Smarky? Anyway, so here's our big boy over in Fusion. The nice thing about Fusion is their sculpting workspace is super easy to just do, so like freeform. It's not as precise as doing the surfacing, but it's just a million times easier. All you're doing is kind of dragging these like points and lines and faces around, but you can kind of get close to your final shape really quickly. I mean, it took me like, I don't know, 10 minutes to get to this point. So, but
Matt
I find
Fender kind of like Blender.
Yeah, yep, like Blender. Somewhere there's a way to expose the polygon behind this shape, right? So there's like a polygon that's driving it, with points that are like way out
Smarky
here.
FPV Thursday unless my wife tosses me over the side.
Now, why would she do that? You're so much fun to be around with in small spaces. Okay, yeah, so anyways, yeah, the downside to like the sculpting thing is like doing this duct around the cowl. I got like a really cool airfoil shape, real easy, but 1 2 3 4 5 6 7, I have 7 segments. If I go down to like 4 segments, it's not a circle anymore. It's like got flat spots in it. So that part of this like sculpting is not awesome. Like I said, it's not as accurate. I'd be willing to bet that this is not a perfect circle, but you can kind of dial in your shape so much faster using this. What I'll probably do is get the shape close and then export it back over to SolidWorks to do the detailing, like to cut my hole for the battery. That I would do over in SolidWorks. Cutting my holes for motor mounts and arms and all that stuff. I'd probably do all that over in SolidWorks. It's gonna be faster over in SolidWorks for that stuff. But now that I'm kind of building like this, I'm thinking maybe even a third arm support the outside of the duct. But anyways, well, that's kind of what I was up to. You can see I changed the shape of the bottom of the duct, got it angled, have it intersecting the main body, right? So now that it's intersecting the main body, I can just put a like nice fillet on there. That'll be real slick. So, anyways, plenty of things to work on over here. Tomorrow I'll be outside most of the time. I've got tons and tons and tons of stuff to move. It's amazing how much crap I have accumulated in 10 years or 11 years or however long I've been here. Amazing amount of stuff. So I got to keep going through all that crap tomorrow, making room for the new setup. So I'll see everybody this weekend, hopefully. Guys, good luck up in Canada, and I'll see some of you for our indoors on Sunday. And yeah, that's it for me tonight. All right, thanks for sticking with me. All right, see ya.